One more. Can we get one more? Well, I guess that'll have to do for now. Good afternoon, everybody. Hello, hello. Today is going to be a work day. There's not a whole lot. I'm going to share with you the answers for the previous problem set from technically assigned Monday that you worked on yesterday. And then you can get started on today's problem set, the continuation, the sequel, the part 2. So without further ado, here they are. The first problem, and I say problem, but really like a fair half of these are more like exercises. Okay, you didn't really implement much of a problem-solving strategy to answer them. Pretty straightforward, but we need that practice and review as we go. So here we go. How many different line segments appear? Remember, a segment goes from end point to end point. So there are 10 total. Here are all the possible combinations. This one actually reminds me of the handshake problem, okay, counting how many possible handshakes between two people, because notice we have AB, but we don't need to list BA again, okay? That would be redundant. It's the same segment, no matter how you orient the letters, right? Number 7, we are finding the following distances between points on the number line. So this is basically just subtraction. You could have done this in 2nd grade, okay? But it's a fundamental building block of the rest of geometry. The fact that we can measure anything stems from this right here. So there you have the measurements there. 4.34, 1.91, 6.65, and 4.22. Number 9 now has you naming the angles. So altogether, we have this top angle here, BAC, or you could call it CAB. The order doesn't matter so long as A is in the middle. We've also got the large one overall, BAD, and the other small one, CAD. The two adjacent angles would be BAC and CAD, these two small ones that combine to make the large one. Questions so far? All right, let's keep going. How many different angles less than 180, okay, so we're not looking at going around the outside here, reflex angle things, less than 180, are there in the figure? There are 10 total possible combinations stemming from AOB, AOC, AOD, COD, right? 4 of them are obtuse, 6 of them will be acute. You do not have to list them here. But if listing helps you count, go for it. We're 15. Now we are computing angle measures based on given information. So we already know that this angle here is 55, this angle here is 150, and then this one is 120. So we got lots of intertangled overlapping here. So be careful. AFB is 60 degrees. We know that because all the way around is 180, and this piece is 120. So 120 plus 60 to make the full 180 band there. And then similarly, CFD, to find this gap, take the 150 here and subtract off the 55 and the 60 that we just found to leave just this piece. And last one for level 1, dividing up the plane into regions with a number of lines. We found just from those 2 lines that the number of regions differs depending on how many intersections we create. So we're going to make as many intersections as possible to create as many regions as possible. And here's a table summarizing the results. 3 lines get you 7 regions, 4, 11, 5 gives you 16, 10 gives you 56. Oh my goodness, what's the pattern here? Well, it turns out 4, 7, 11 is 1 more than the triangular numbers 3, 6, 10. So it's n times n plus 1 all over 2 plus 1. Told you, those triangular numbers, that little expression is going to be super handy dandy. Have it in your back pocket at all times. Questions from the level 1 problems. No? All right, let's keep going. For those that did level 2, there are 8 different rays in this figure. We cannot simply reverse the name as is. If I swap the letters A and B here, I also need to swap the direction of the arrow, because this is ray AB is different from ray BA. This is going from B through A. This is going from A through B. So they're pointing in different directions. Number 10 presents us with this quadrilateral figure here, names all the different angles with Q as the vertex. We could have PQR or RQP, right? You can go backwards. Doesn't make a difference. PQS and SQR. Now the adjacent angles will be the ones centered around Q and S. So we have PQS and SQR, and PSQ and RSQ. Next up, given this diagram with these 3 straight in a line here, how many different angles total? 6. 2 of them are obtuse, and there are 2 supplementary pairs. One is WSV and VST, and the other is WSU and UST. Okay. Next we have another one of these. Here's information in the diagram. Compute the missing angles. We have this is a right angle. We have this much 72. This is 150. So to get AOB, I would take the 150 minus the 72. Simple enough. And to get BOC, I only have things that overlap, so this goes to, I would have to take 150 minus the 90 to get this much, and now I can take 72 minus COD to get BOC. Okay? Or the 90. Oh, I forgot. That would work too, just looking at this, right? Since you know AOC is 90, and you know AOB, so 90 minus the 78 to get the 12. Of course. Sometimes I go for the more complicated one first. All right, 18. 18 is a little interesting. You've got to bring in some algebra skills here. We can see from the diagram that 1 and 2 are complementary. We're also told measure of angle 1 is 14 less than twice the measure of angle 2. What the heck does that mean? If it sounds like they're reading off an equation, there's a good clue that you should use a variable and write an equation. Right? In fact, here you're going to write 2 equations, solve the system of equations to find angles 1 and 2. There as 55.33 and 34.67 degrees, respectively. Any questions on level 2 problems? All right, right, then here are the level 3s. First up, we have another set of distances, this time using irrational numbers instead of decimals, square root of 2 in this case, and since they're all square root of 2, this is actually almost easier than the decimals. This is just all multiples of root 2. So you've got 6, 5, 2, and 9 root 2 there. Get used to dealing with radicals and these irrational numbers. They're going to be all over the place in Algebra 2. Here we have a couple more right equations solve the system. So we know, again, these are complementary, but this is 4 times as large as that. So you have A equals 4 times B, and A plus B equal 90. Solve for A, you get 72 degrees. Similarly, set up a system for X and Y here. Solve to find X is equal to 123 degrees. 1, 2, 3. I like when it does that. And then finally, similar to the lines dividing the plane into regions, we have points create how many lines? So 3 points can create at best 3 lines. What about 4 points? 5 points, right? 4 points at best can create 6 lines. 5 is 10, 6 is 15. So 6, 10, 15, 3, 6, 10, 15. So these are still the triangular numbers, but they've been shifted a little bit. So instead of n times n plus 1, we have n times n minus 1, all divided by 2. Right? So it's very similar, gives you the same numbers, but in a different location. Okay? So how many n's do you need before you get the first triangular number? Questions there? No questions? All right. Well, then you have those now as examples to reference. As mentioned, some of these are more like exercises. The problem set for today is all problems. There's just fewer of them. And, oh, there's some really good ones in there. I can't wait to take another look at them on Friday. So you have the rest of the day to work. Begin.